afternoon, everyone. My name is Pravin, and I'm taking care of R&D of engineering polymers at the KLJ Group. First of all, I would like to thank the Rail Analysis team for conducting such a beautiful conclave, and to the management team of KLJ for giving me an opportunity to introduce the company and the products to such a learned audience. So what we will discuss in this topic is basically about KLJ. Many people know KLJ for plasticizers, but there is more to this group, which we will discuss along as we go ahead. Then we will discuss about various polymers which can be used in railways application and the properties which they can impart, like thermal, chemical, mechanical, or corrosion resistance for that matter. Then we will also discuss about the identification and selection of materials based on the specific application requirements. Briefly, we will touch upon the products offered by KLJ into railways. Another important material is fiber reinforced plastics. Again, the properties that they impart in railways and their applications overseas, and how we can translate those applications into our Indian railways. And finally, we'll discuss about the future developments that we are currently doing, which will help us and the railways to incorporate into their new or existing projects. So KLJ Group started its journey in 1967. Currently, we are the largest manufacturer and market leader for plasticizers and polymer compounds in South Asia. Also, we are the largest manufacturer of chlorinated paraffin segment across the globe. The current annual turnover is USD 1.4 billion. The presence is in 90 countries with sales and distribution network. And we have operations in 3 countries. And the team size currently comprises of around 2,200 employees. With several regional certification, international certifications, process, products, and system certifications. This is not a comprehensive list, this is only the representative list. Operations, as I said, in India, we are in Silvassa, Bharuch, in Kandla, and Agra. We also have a plant in Thailand and in Qatar. I said we are present in around 90 countries. Plasticizers, we are the largest manufacturers of plasticizers in South Asia, and we also have a backward integration facility for phthalic and malic anhydride, which are the components for manufacture of plasticizers. The range of plasticizers include phthalate, maleates, terephthalates, ESBO, and chlorinated paraffins. These are few of the grades: phthalate, specialty plasticizers, maleate, polymeric plasticizers, we do have ESBO. Plasticizers, this goes into variety of applications like medical devices, in perfumeries, cosmetics. In railways, basically they found an application into wire and cable compounds, vinyl flooring, leather cloths, flexible tubings, lubricants. So as I said, there is more to this group. So polymer compounds is another area where KLJ Group is highly active into. We are currently doing around 9,000 plus metric ton per annum of polymer compounds. The polymer compounds facility is in Agra and Silvassa, with state-of-the-art R&D center in Silvassa unit. In polymer compounds, we have compound which is as soft as lower than shore A hardness, means it is highly soft, you cannot even handle it, it is so soft. And we have very hard polymers as well. So we have PVC compounds which goes in for applications of medical tubings, footwears, then polypropylene and engineering compounds which find applications in automotive, white goods, electrical, railways, defense. PE compounds, again mainly for wire and cable and coatings on the pipe. Then apart from these compounds, we also have a master batch division. We also make some special functional master batches like anti-rodent, anti-termite. Polymer compounds, they find applications into medical devices. We give compounds for applications like blood bags, IV sets, inhaler housings. Then automotive, we are there in bumpers, dashboard. In appliances, all coolers, geysers. In defense also, we are there. Few of our products are approved in defense. In railways, we will cover the railway applications as we move along. CSR activities, yes, we are there. Sustainability, we have few compounds based on sustainable products. In railways, basically, why do we need polymers, or what polymers impart in railways? Basically, polymers, some of them are self-lubricating, so we do not need lubricants, so there is a dry operation. Then some polymers, through their dampening characteristics, can reduce the noise. Then reduce size or reduce weight is an important aspect, not just from fuel efficiency, but also from other functional aspects, which we'll discuss. Flexible design, apart from imparting styling, flexible design has also other functional aspects, which we will cover. Wear and corrosion resistance is again very important for longer service life, reduced maintenance, and as one of the speakers yesterday spoke about the impact of corrosion on the functioning of railways. Dimensional stability is important for polymers, which are kind of used in the applications where mating parts like gears are used. Transparency and diffusion, like polycarbonate, PMMA, they can be used for lighting applications, mood lighting. Fireproof, mostly all the polymers can be made flame retardant. Some of them are inherent, others can be made flame retardant for the increased passenger safety. Heat resistance is another area where you need polymers where they are in touch with the applications closer to engines. Chemical resistance is another area where the components or the applications, when they are into service, they come in contact with lubricants, greases, oils, or during usage as well, there is a spillage of tea, coffee. So the components should be able to resist those. So what the properties, what we discussed in the previous page, not necessarily all the polymers, a single polymer can impart those. So depending on the application, we need to choose the polymer. What you see here is the classical pyramid of polymers. If you move from left to right of your screen, you get crystalline polymers which have better chemical resistance. And if you move from bottom to top, you have polymers increasing in mechanical strength, thermal resistance. You can see some of the polymers you can use as high as up to 240 degrees, and there are some ultra performance polymers which can be used up to 450 degrees C as well. Specific strength is another important aspect in selecting the polymer, which represents basically the strength to weight ratio of the material. You can see the light gray bars represent metals like stainless steel or aluminum, and the orange or blue bars represent some of the high performance polymers reinforced with inorganic fibers like carbon, glass, aramid. So they are at par with metals or sometimes overperform them in terms of specific strength. The applications, what these polymers can go into, there is a myriad of applications, interior and exterior, like MCBs, vinyl flooring, body structures. Cable conduit pipes is another area where these polymers are used. Thermoplastic elastomers are required where you need a soft touch or the feel or even the pads for cushioning. There are technical parts which can be made out of these polymers like screws, fasteners, gears. Again, in this chart, you see the applications based on their usage, like exterior, interiors, technical, and infrastructures. So the highlighted ones with red are the areas wherein we give a compounds into like air ducts, conditioning, cable clamps, switches, switch gears, cables. So these are a few of the products which are offered by KLJ. This is a polycarbonate flame retardant UV stabilized product. This goes for the ear vents of the metro trains. This is a V0 product. It is UV stable and it complies to R2HL3 rating as per EN 45545-2. Another product is based out of polyamide 6. This is a halogen-free flame retardant product. This is also phosphorus-free. Application is again conduits and fittings for cable protection conduits. This is V0 rated right up to 0.4 mm thickness. It has excellent chemical resistance. Another product is PBT and polyamide 6 with higher comparative tracking index. This is required where you have higher voltages. This is used in electrical switch gears and surge protection devices, basically into applications like terminal blocks or MCB, RCCB housings. This is again halogen-free product with a glow wire resistance of 960 degrees C. Another product based out of PVC is for door sealing profile of a metro train. This is a compound with an elastomeric soft feel and a low compression set. Another application is for wire insulation. This is a product which has a very good wet insulation properties and it goes as per the RDSO specifications. Apart from insulation, we also have some sheathing compounds or jacketing compounds, again in PVC. This product meets the ST1 requirements of IS 5831. Apart from this, the FRPs, as I said, they are very important. What they impart is high strength to weight ratio. Because of the low weight, they give a lot of fuel efficiency. With the increasing demand of advanced technologies, luxuries, high load of ACs or entertainment system, and increased passenger safety, fire protection devices, it is estimated that there is almost 35% increment in weight due to this additional requirements. So you really need materials which are very high in strength as well as low in weight. So that's where FRP comes into play. Also, due to lower weight, the track wear is less, which is an important aspect. Flexibility in design, superior styling it imparts. Apart from superior styling, when the train enters the tunnel, there are compressive waves which hit on the tunnel, and it propagates through the entire body of the train. So you need a very stiff material which can handle those compressive waves. So FRP has those properties. Excellent corrosion resistance is what we discussed. Also lesser noise and lesser vibrations. It adds to the comfort of the passenger. These are few of the applications which are currently used in overseas trains, like seats, baggage places, toilet features. Our bimodal tram Korea is made out of glass fiber reinforced composite. Then monorail car bodies, windows, sidewalls, body shells in US are made out of e-glass epoxy composites with carbon glass or aramid fiber. Then you have a rail car body structure of CG Rail Germany. This is a structure which is made out of carbon fiber reinforced composites. It's around 22 meters long and 25 mm in wall thickness. These are few of the developments we are currently working on to help us and railways to implement in their existing or new projects. Foaming grade polymers for low weight. We already have a solution in EVA polyethylenes. We are working on other polymers. High performance polymers for extreme heat. Those you saw at the top end of the pyramid, we are working on those. Then special grades of TPV, thermoplastic vulcanizers and thermoplastic elastomers for sub-zero applications. Special grades of polymers for cable sheathing we are working on. Low thermal expansion polymer compounds, again, where they go into assembly or you need very high, very low tolerances in terms of dimensions. Electrically conductive polymers we are working on. Thermally conductive is another area where you need heat dissipation PVC alloys for high temperature applications. Yeah, as they say, only a human mind can remember 40 to 50% of what has been shared. So if you need further information, please contact these two individuals. One of them is me, other one is my business head. And I would like to thank you with this. There is a stall at the end of, right at the end. You can visit us. Thank you so much.